Hello everyone. Today we will be studying about stress distribution in soil. How the stress distribution will be done in the soil sample. The first thing for the stress distribution, there should be some self weight. Then only there will be some self distribution of the soil also. And the next one is whatever the structure it is, the load applied on the structure, that should be below the surface. That should be below the surface. Then only it can be taken into consideration. And you will be having vertical stresses also, the stresses which are transmitted due to the soil layer, and that because of this vertical stresses which are transmitting and in the soil, whatever this is, it causes because of the settlement. Whatever the foundation settlement is done for a building or bridges or embankments is taken into consideration. Not only this, there will be some small magnitudes which are the stress are directly proportional to the stress and strain stress and strain for a soil sample. And these magnitudes whichever these transmitted by the structures, these are the small substances, like small loads only. So that the elastic theory in this thing will be taken into consideration. So this elastic theory determination of stress and soil distribution is taken into consideration. And for this stress and strain parameters, for the application of this elastic theory, which will be determining the stress distribution, Young's modulus and Poisson's ratio are the major parameters which are taken for stress and strain curves. The vertical stress which is done by self weight of and geostatic stress is given by the equation, where this gamma is nothing but the unit weight of soil, and sigma z in the vertical strength in the vertical stress, the soil is depending upon the z and surface also. That means it is on the self weight of the is taken into consideration. And this vertical stresses which are applying on the soil, the adding of these vertical stresses, there will be some algebraic sum of this stress. So that stress will be the self weight due to the stress, whatever the stress which is transferring from the structured whatever the structure it is loading. Next we will be seeing the Bernoulli's equation. That means Bernoulli's theory. This Bernoulli's theory point load. How this Bernoulli's theory point load in if you see this Bonki's theory, this theory was in 1885, has been given the solution for this application. As for the point load, for the point load we are taking into consideration. For this also, this is the whatever the surface which are taking into consideration, that surface is homogeneous, elastic and isotropic and semi-infinite medium also. And this is an theory elastic. And what are the assumptions made here? As we all know, the assumptions which are made for this is an elastic, homogeneous, isotropic and semi-infinite medium also, which will be extending in all directions of the surface. The medium obeys the Hooke's law. That means they will be obeying some Hooke's law. The sulfate is also ignored here, and the initially the soil will be unstressed. And the change in the volume of the soil also will be changing depending upon the application. That means the load is applied, then it will be taking into neglect. And the top surface of the medium is free for the shear stress. Continuous stress is considered for the existing in medium. And the next one is symmetrically, there will be a stress distribution in z direction also. So that let us consider a point load Q and single concentrated load acting on the surface on point O, which means being taking the origin of XYZ axis as shown in the figure. As you can see in the picture, you are considering this point Q as your consideration, so that the point O is also our center of the origin, which we take in X direction, Y direction and Z direction in the same way. So that if you see here, let us now find out the stress components for P. Whatever the stress components which are there for P, we are going to find out. We are going to find out this based upon the x direction, y and z direction, and for this radially horizontal distance is also taken into consideration. So this radial horizontal distance we will be taking as r and the vertical distance as z from the point O. Point is nothing but O is nothing but our origin, from where we are taking that point we will be taking into consideration here. So using all these arithmetic stresses, we will be using this expression, that means at a polar radiant stress, as you can see here, the r is taken as your point here. So if you see where the polar radiant coordinate is p now, so that you will be getting what is a coordinate which is related to at a point p in the, and this is also for cylindrical circles. That means the cylindrical circles, when the vertical stresses are being applied and tangential, you will be getting an equation for this also. So that if you see here how this Bonkius influence factor is taken into consideration, and next you will also see what is the influence factor, that means based upon the ratio, that is r by z, as this is nothing but an dimensionless, and here we can also see the KB factor, that means how it is multiplied by shear stress and all those things. Even the vertical stress at a point also is being taken, that too with the radial distance, and even the depth z also is considered here. And then because of that you will be finding the influence factor, that is r by z, by the ratio which will be multiplying by q by z square. That is nothing but q is a point which we are taking into consideration at the diagram initially if you see, and z is nothing but the xyz directions which you are taking into consideration. Now there is because of this the internal the vertical pressure and this point load directly will be interlinked. Based upon that you will be getting some expression depending upon the components which are being displayed with the help of a displacement. That displacement we will be taking as u, v and w, so that you will be getting the formulas depending upon that. And next we will be seeing what is pressure distribution diagram. This, as we all know, this pressure distribution diagram, this will be giving the vertical pressures. The vertical pressures are majorly necessary for this stress distribution. As this vertical stress distribution, the first one is isobar diagram and the second one is horizontal plane. As we take this horizontal plane distribution according to the vertical, the z units below the surface is also taken into consideration, and the third one is the pressure distribution will be in the vertical direction only, vertical stress only. At the distance, whatever the distance which you are taking on the line, that will be single and concentrated load is taken into consideration here. And if you see in this diagram here, that means the q and distance, all the vertical stresses distribution will be taken into z axis, and the q is the point where the stress distribution is taken, and r is the radius, and the red color line which is indicating this is an isobar. Whereas this isobar and pressure bulb, how this isobar and pressure bulbs are taken into consideration, we will be taking in the next session. Thank you.